In our universe, the primary sources of light are stars. From infrared light to visible light to ultraviolet, all stars in the universe, including our sun, emit these forms of light. Our Milky Way has several hundred billion stars. Compared to our solar system's only star, the sun, the other stars in the Milky Way have a lot of diversity. Some stars are big and some are small, but have you ever thought about the stars outside our Milky Way? Do the stars in other galaxies emit light like our sun? Are their sizes and structures like our sun? In today's video, we will learn about the stars in other galaxies. Our universe contains trillions of galaxies. Based on the structure and shape of the thousands of stars, gas clouds, and galaxy within these galaxies, they can be categorized into four main types. For example, our own Milky Way and our neighboring Andromeda galaxy are both barred spiral galaxies. However, the light and structure of the stars within different types of galaxies can be quite different. So let's start learning about the different structures of stars within the various galaxies in our universe. The first galaxy we'll discuss is the elliptical galaxy. The name of the elliptical galaxy comes from its shape, as it is oval or elliptical. These types of galaxies are among the oldest galaxies in our universe. Due to the low amount of gas and gas clouds in these galaxies, new star formation is very rare. Hence, we find mostly ancient stars in these galaxies, known as population 2 stars. Stars in our universe are classified into two populations. Population 2 stars, formed within the first few billion years of the universe, and population 1 stars, formed 4 to 5 billion years ago from the remnants of dying stars, containing small amounts of metals like oxygen and carbon. In our Milky Way, both population 1 and 2 stars exist. Our Milky Way, a barred spiral galaxy, has more population 2 stars, older stars, towards the center, and more population 1 stars in other regions. Our sun is a population 1 star with over 1.4% metal content. However, elliptical galaxy stars are mostly population 2 stars with little to no metal content. Additionally, being older stars, the light and temperature of these stars are lower than those of stars in our galaxy. Now let's move on to irregular galaxies. As the name suggests, irregular galaxies have no definite shape or structure. They can be of any shape with no fixed type or size. They contain both population 2 and I stars. The stars here can be brighter or dimmer. Some irregular galaxies can even orbit larger spiral or elliptical galaxies as satellite galaxies. For example, the nearest irregular galaxy to Earth, the Large Magellanic Cloud, orbits our Milky Way as a satellite galaxy. It mostly contains newly formed population 1 stars, similar in brightness to our sun. Finally, let's talk about dwarf galaxies. The smallest known galaxies are called dwarf galaxies due to their small size. Dwarf galaxies are of two types, irregular dwarf galaxies and elliptical dwarf galaxies. Just as we learned about irregular galaxies, these small irregular galaxies are called irregular dwarf galaxies. Like irregular galaxies, irregular dwarf galaxies contain both young and old stars with more young stars. On the other hand, elliptical dwarf galaxies are smaller versions of elliptical galaxies, containing mostly old, dim population 2 stars. Dwarf galaxies can be 100,000 times smaller than the galaxies we discussed earlier. In our solar system, between Jupiter and Mars, there's an asteroid belt containing asteroids and many dwarf planets. Beyond this asteroid belt, at the edge of our solar system, lies an icy asteroid belt called the Kuiper Belt. How were the asteroid belt and Kuiper Belt formed? To learn about the formation and structure of these belts, click on this video. If you enjoyed the video, subscribe to the Insights of Cosmology channel to stay connected with us.